wrong color.
You can be in whatever color you want.
We saw yesterday inductive reasoning, making reasoned conclusions based just on seeing patterns. Today we're going to take you, my goal of, not just today, but this course in general, is to take you from someone that makes conclusions just on what they see, to someone that makes conclusions based on evidence and based on logical arguments. If you're a deductive reasoner and you're using deductive reasoning, you'll make conclusions based on logical arguments. Based on logical arguments. Our first law of logic that's going to be true, that we will use, is called the law of detachment. The law of detachment says this. It says that if you know that the hypothesis of a conditional statement is true, then the conclusion must be true. So I'm gonna ask you today to think very logically and not think about the statements in and of themselves, but think of the flow of logic. To think of how this detachment and how the rules in place, what do they tell us must work. So in particular, if the measure of two angles adds to 180, then they are supplementary. The conditional statement is, if the measures add to 180, then they are supplementary. It is our conditional statement. The next statement is what really is important. The next statement tells us for sure that the case that we have presented is that this is true. The two measures, the angles that we have, are 65 and 115. We have the case of this. What do these two angles add up to? Those angles add up to 180 degrees. Okay? So logically, what do we have? Logically, we have the hypothesis and a conclusion. And I'm telling you that the hypothesis is true. So logically, what can we conclude?
It's true.
That the conclusion is true. And namely, the conclusion in this case is that the angles are supplementary. Here's maybe we'll take it a little bit farther away from the math world then. Here's the conditional statement. Mildred goes to the movies every Friday and Saturday night. Okay? Absolutely. So the conditional would be if Friday or Saturday, then Mildred goes to the movies. Well, now I tell you some more information. I tell you that on this particular day, it happens to be Friday. Okay? So then what new can we conclude? Is there anything we can conclude? That she's going to the movie. We don't need to do...
That's a lot of movie ticket money.
Yep.
Hope she brings us popcorn. That'd be expensive.
Example here and see how this is different than the previous one. And there's a typo here. These are supposed to be the same people.
Oh, okay. I think it should be Brad.
Those are supposed to be the same people.
Every night.
Okay.
No joke.
Here's our conditional statement. Our conditional statement is Matt plays Gears of War 3 every Saturday night. So let's rewrite this conditional as an if-then. Let's make sure we know where the hypothesis and where the conclusion is. Okay. Okay. What's the conditional here?
If it's Saturday night, then Matt is playing Gears of War 3.
Then Matt plays Gears 3. We know that Matt's playing Gears of War 3. So what now can we conclude? Absolutely nothing you can conclude. There is no new conclusion here. Here's the reason. What did I tell you is the situation? What part, logically, is this telling us? He's playing Gears 3. What part of our conditional statement am I giving you information about? The conclusion. I didn't tell you anything about the hypothesis. The law of detachment says that the hypothesis must be true. If I don't tell you that's true, then there's no logical conclusion you can make. Now, maybe you know Matt personally, and you can rewrite a different conditional statement so that maybe it works. But for this logical statement we've created, this does not flow. Because the information I give you is about the conclusion. It's not about the hypothesis. Logic only flows from hypothesis to conclusion. It doesn't go reverse. You better rewrite your statement, and then we'll make a new assumption about that. This conclusion, this statement does not jive with the hypothesis. Therefore, there is no new conclusion. Our second law of logic is called the law of syllogism. Okay, it's a fun word. It's one of my favorite words. Law of syllogism. Maybe a better name for this might be, I like to call it the chain rule of logic. Okay? It follows like this. If you can link together conclusion to a hypothesis, then we can link together the logical statements. And maybe symbolically it would look like this. If A, then B, if you have one statement, if something, then something else. If that same something else, then something new. The chain rule, so if I just very symbolically said that if a statement, then something else. That same conclusion now becomes a hypothesis, then something new. A new statement you could write is we could link together a conclusion to a hypothesis and create, and then you could create a new logical statement. This implies that if A, then C would be a new conclusion you could write, or a new logical statement. Okay?
So where do these be like?
We finished it. Good. You've already read it. If you take English here, then you will or have read Of Mice and Men. If you read Of Mice and Men, then you read one of my favorite books. Yay, me, my favorite book.
You like it?
Love that book.
It's sad at the end.
Okay.
I thought it was one of my
In any case, what's a new statement using the law of syllogism that we can make here? Eunice?
If you take English at FHGeo, then you will have issues to your book.
Absolutely. If you take English at DHS, then you will read One of my favorite books. How about the next one, a more algebraic one? If x squared is greater than or equal to 25, then x squared is greater than or equal to 20. If x is greater than or equal to 5, then x squared is greater than or equal to 25. Oh, this one doesn't jive just as easily as the previous one. But I claim that we can still use the law of syllogism here. Okay? I claim that you can. That definitely you will. It's a true claim. Right? Definitely can. Okay? Let's think symbolically here. What do you think symbolically? Here's how about x squared greater than or equal to 25? Let's call that thing like A. Are there any other claims? Are there any other conclusions or hypotheses that match up with x squared is greater than or equal to 25? Okay. How about some other claims then? X squared. Is there any more x squared is greater than 20? No. So then this one, why don't you see? What would be? Let's see. Sure. Do we have any letters that match up that are a hypothesis and a conclusion? Do we have any matching letters? First of all.
Yeah.
Yeah. We had an A and an A. Okay. Is one of them a hypothesis and one a conclusion? Yeah. Here's a hypothesis. There's an if. There's a conclusion. There's a then. So let's rewrite these statements so that the conclusion comes before the hypothesis. Or maybe you could quickly either in your head think about it or write it down just very formally. Maybe a better way to write this would be if x bigger than or equal to 5, then x squared bigger than or equal to 25. And if x squared bigger than or equal to 25, then x squared bigger than or equal to 20. Notice how I matched up the same logical arguments. One, the conclusion first, and then the hypothesis. So using that notation, this would be like what? This would be like C, A, B. Maybe that'll get in the way. Maybe you don't want to do that. Sure.
Can B and C switch?
Sure. If you're obsessive compulsive like I am sometimes, then you can flip them so the letter farther down the alphabet's first, but it shouldn't matter. And if C, then B. If B, then C. If you don't like those letter combinations, you could even relabel them all and say A, B, B, and C if you wanted. However you want to do it, as long as the two same letters match up.
Okay, this really confuses me. I get it.
So what's the conclusion then? Forget it. Not even worrying about the letter things. That probably confused more than helped. Rewriting them so that a conclusion matches hypothesis. So then, what new statement could we make? What new logical statement could you then make?
Is greater than or equal to 5, and then x squared is greater than or equal to 2.
Would be a new logical statement you can make. Thursday, then Caitlin washes the office. If Thursday, then Caitlin will have homework, more specifically geometry homework. Okay. What new statements can we make from this, Joel?
Caitlin's watching the office,
Don't think you can claim that.
It is there's
Is there, what new statement, if any, can you conclude? There's no new statement to conclude here. Can anyone see the reason why?
Because there's nothing in between.
Joel, what's the reason why?
Because you could have geometry every night, or you could have the office every night, or watch the office every night.
Okay, so in this world of this example, that would be kind of like the base level. Let's go up to just the rules of logic level. Why logically doesn't this fit?
But you took A and you said it's a Thursday night and then you're watching The Office, but you didn't say like if you're watching The Office then
We're not linking a conclusion to a hypothesis. We're linking a hypothesis to another hypothesis. The chain rule, or the law of syllogism, says that we have to link conclusion to a hypothesis. It doesn't link together. It doesn't flow. This is like an if. This is saying if A, then B. if A again, then C. There's nothing new to conclude here. These two have to link up, have to match if you want to use this chain rule, this law of syllogism.
What two?
A conclusion needs to link with a hypothesis. In this case, there's nothing there. There's just two statements that are independent. We can't match them up. Now, if you had a statement that said something about what does Caitlin do every time she watches The Office, then you could get something. Or what does Caitlin do if it's something, then it's Thursday. There might be a statement you could use to link, but we don't have any of that here. So we're forced to conclude nothing logically new could happen. Okay.